The purpose of this video is to provide an overview of some of the important concepts relating to the time value of money, otherwise known as TVM, time value of money. A basic way to examine what the time value of money is through an example. So let's take a look. Let's say that we are going to deposit $100 in a savings account at 5% interest. And the question is, how much will you have in 1 year, 2 years, or 3 years? In this case, the $100 is a present value because that's an amount at this point in time. The future value is going to be how much we're going to have 1 year from now, 2 years from now, or 3 years from now. So here's the concept. To calculate a future value is equal to the present value multiplied by 1 plus the interest rate. So in this case, $100 times 1 plus 5% is going to be equal to $105. And that's pretty straightforward. If we invest $100 at a 5% rate of return, in 1 year we'll have an extra 5% or $5. So we will have $105. However, in 2 years we will have $105 once again times 1.05 is going to be equal to $110.25. So in this case we are earning a little bit more than $5 in interest, because now we are earning interest on the interest. The $5 that we earned in the first year is now accumulating interest. In the third year, we will have $110.25 multiplied by 1.05 is going to be equal to $105.76. So this earning interest on interest is called compounding, and compounding is used to find a future value. Another way to find the future value, rather than making this calculation year after year, we can say a future value is equal to the present value multiplied by 1 plus the rate of interest to the power of n being the number of time periods that interest is accumulating. So in this example, if we took the $100 multiplied by 1.05 to the power of 3, we would come up with $115.76. Now, the opposite of compounding is called discounting, and it's used to find a present value based on a future value. So let's take a look at another example. Let's say that we have $115.76 3 years from now. Well, if we take that future value divided by 1 plus the rate of interest, it's doing the exact opposite of what we did up here. So 115.76 divided by 1.05 equals 110.25. 110.25 divided by 1.05 equals 105. 105 divided by 1.05 equals 100. So another way to find the present value, just like we did up here, is we have a shortcut. If we take the future value divided by, do the exact opposite. The future value divided by 1 plus the rate to the power of n equals the present value. So $115.76 divided by 1.05 to the power of 3 is equal to 100. So another way of saying this is that $100 today compounded at a rate of 5% is equal to $115.76 3 years from now. In addition to that, $115.76 3 years from now, discounted at a rate of 5%, is equal to $100 today. Continuing on, the next concept that we want to talk about is something called an annuity. It states, an annuity is a series of equal payments at equal intervals for a specific period of time. An annuity payment that starts at the beginning of each period is called an annuity due. Annuity payments that begin at the end of each period is called an ordinary annuity. The most common type of annuity is a loan payment. Any type of monthly loan payment that you have is set up as an annuity. Other common annuity types might be a monthly phone bill. If your phone bill is the same amount year after year or month after month, and you have a contract for 2 years, that 2-year period is reflective of an annuity. Here's another concept. Notice that in our abbreviations, we're going to use a capital N, and N is equal to the number of compounding periods per year. If there are more than one compounding or discounting periods per year, then N is equal to the total number of compounding or discounting periods per year multiplied by the number of periods per year. Here I made a quick correction. N is equal to the total number of compounding or discounting periods, which is equal to the number of years that a loan covers multiplied by the number of periods per year. In addition to that, a periodic rate identified with a small r is equal to the annual rate divided by the number of periods per year. So therefore, if there are more than one compounding discounting periods per year, then for an annual rate, the number of periods per year is equal to 1 period per year. However, monthly would mean that there are 12 periods per year. The annual rate is going to be equal to the the periodic rate, as with the R, is equal to the annual rate divided by the periods per year. Let's look at an example. The example is we have a 5-year loan with monthly payments at 12% interest. Therefore, with monthly compounding, the total N, meaning total number of periods, is 5 years times 12 payments per year. You will have a total of 60 periods or 60 payments. The monthly interest rate is going to be the annual rate of 12% divided by 12 periods per year, or 12 months, equals 1% per month. Therefore, the total number of periods and payments will be 60, and the monthly interest rate is 1%. Okay, that concludes the introduction to the time value of money concepts. We will continue on with some of the other concepts and some of our other worksheets in the next video.